two events are said to be mutually exclusive if their intersection contains no sample points, so they have no possible points that can be in common. As you recall, our additive rule of probability is the union of two events, or the probability of the union of two events, is equal to the sum of the individual probabilities minus the probability of their intersection. Well, if there are no points in the intersection, the probability of nothing is 0. So we don't need to write that again. Another term that means the same thing as mutually exclusive is the term disjoint. So you might see that in your reading somewhere as well. So as an example, we're going to roll a die and make event A be the result of that die roll is even. Event B will be the result is a 3. Now the even numbers for a die roll are 2, 4, and 6, none of which is a 3, so we are going to have mutually exclusive events. So let's see what we can do about our Venn diagram here. Alright, close enough. Alright, so this will be event A, our left bubble, and event B is our right bubble. Okay, remember there are no points in the intersection, so there will be nothing written down there. Unlike one of the previous examples where I wrote down the actual number of points in each of the sections, I'm going to write down the actual values, then we'll have to count them up. So the even values are 2, 4, and 6. The odd number 3 is right here, and the other two odd numbers are 1 and 5, and they're in the outskirts they're neither A nor B, so they're in the outskirts of the box part of this. So using the actual additive rule of probability, we have probability of the union is equal to the probability of A and B. And I'll write this in, but again, this is going to be 0. Because they're mutually exclusive. So the probability of A is going to be 3 out of 6. B is 1 out of 6. There's one value there, there's 3 values here. And this is 0. So our final value is 4 out of 6, or you can reduce it to 2/3. And that's how you deal with mutually exclusive events.